10 Commandments of Distributed Systems Management. What we're going to be doing in this session is looking at 5 of the key issues that surround the problems of managing multiple platforms of different kinds. And we'll put together some findings, 10 commandments, 10 things to watch out for as you move forward in this complex and challenging arena. I'd like to use this chart as a proxy for the dilemma of the distributed environment. We're in a world where budgets are being cut. So people say, look, I can help you in the IT organization. I'm going to cut your budget too. But we'll give you some help. We'll replace those expensive legacy systems with these cheap distributed systems in their place. So where do you end up? You end up in domain A, where your budget is reduced, and this scale can be read simply as +5, +10%, -10, -20, -30%. Okay? Here you are. Your budget's been cut. You've gone to alternative technology, and availability, the vertical axis, +20, +40%, -20, -40%. Availability is going down. So you say, gee, I won't have a certain amount of resources, but my end users demand better availability, so I'm going to divert resources in this constrained environment from other projects to solve the availability problem. And I move from domain A into domain B. In domain B, I am spending more money on an annual basis on the problem of availability, which means what? It means other areas are getting even further constrained, but availability still continues to slide. Why is this? Well, partly it's because the tools aren't mature, the procedures aren't in place, you're not exactly sure what the end users mean when they say the system isn't as available as they'd like, so you have to do some work. Eventually, you get it grooved, you pick the right technologies, you make some progress with your end users on setting expectations, and you're able to move into domain C, where you're still spending too much money, the budget's going up, but at least availability is improving. Most of our clients in this space are currently in B, moving to C. They're beginning to actually see improvements in availability, but they have not yet been able to tackle the budget stuff. Domain D is the end game, where you're able to continue to sustain improvements in availability while sustaining cuts in aggregate resource devoted to availability. That is the story for all of the 15 or so systems management disciplines. The first thing that happens is you get less money and service deteriorates. Then you address the issue, and the priority in which you address the specific systems management issue will be governed by the service level agreements you're responding to. Whether they're explicit or not is not important. The scorecard for distributed systems management, costs are going up. If you do it well, you will spend only 2.5 times more money managing a distributed environment than you spent managing a monolithic environment, if you do it well. If you don't do it well, you will spend 9 times more money, effort, and personnel managing a distributed environment than managing a monolithic environment. When you cross this threshold of manageability, things get messy. You know you're in trouble when the system no longer settles down, when it seems to oscillate between bad behaving states of different kinds, when you do something to tune it and something else happens in an apparently unpredictable fashion. And what we're talking about here is not just computer systems, but complex systems of many kinds. The highway system comes to mind. If you have too much traffic on a highway, adding more lanes doesn't help. You think about it, a 4-lane highway should have an average velocity of twice that of a 2-lane highway. Doesn't happen. Why? Because what computer folks call MP effects, meaning you're now looking, 2 lanes over that way and 1 lane over that way, worrying about what people might do, so everybody slows down. You add a lane and nothing happens. If you have a problem with traffic on a highway, the only thing you can do is to scale back the traffic. You put a stop sign or a stop light on the on-ramps, or you force architectural regularities on the system. High occupancy vehicle lanes, special limited access roads for passenger traffic only. You restrict trucks to the right-hand lanes and so forth. You apply architectural regularities or you scale back. The problem is that in the software arena, when you cross this threshold of manageability, you don't get a lot of warning. One day the system worked, the next day the system isn't working. You try to tune the system, 25% of the time its performance improves, 25% of the time its performance worsens, and 50% of the time nothing happens, right? A colleague of mine expresses it this way. He says, when you hit the wall in software, there are no skid marks. You don't know you're there until you're there, and everything's gone to pieces. That in itself is bad enough if it weren't for another trend, and that's this curve here, the spending threshold for distributed systems management. The problem is that if you're in domain C, if you're in this space over here, you are willing to spend money, resources, and people to manage the system, even though it is not manageable in an absolute mathematically provable sense. It cannot be managed, but you're going to try. If you think you're in that domain, scale back, cellularize it, or abandon the notion that you can achieve the level of management that you had expected. Those are your three choices. If you are acquiring a product to manage a complex environment, it's legitimate for you to ask the vendor to show you another client that is running an environment that is, in some senses, at least as complex as the one you've got. Number of servers, number of applications, number of users. Message, beware of the threshold of complexity. The framework vendors are attempting to solve the problem of managing complex distributed systems. We do not believe that any framework vendor is going to solve all of your problem unless you happen to be a shop that is devoted to one platform. If you are an AIX shop, then NetView for AIX will probably meet most of your needs. The reason for this is simply that most of these vendors, IBM, Hewlett-Packard, and Sun, have a natural channel and a set of requirements coming from their customer base that they're going to try to address, either directly through internal development or through alliances. So we expect that since no one will do it, you're going to have multiple. It's our planning assumption that by 1998, 40% of our client base is going to have two frameworks. As I said before, the purpose of a framework is to provide some sort of middleware, some sort of glue to support multiple distributed systems management applications. This is the Tivoli sales pitch from about 4 years ago. If you buy TME, you will be able to run software distribution and job scheduling and performance monitoring and backup and recovery across all of your open platforms. This is appealing. Why? Because the interface that the various Unix operating systems present to these technologies is different. The way you do job scheduling on an AIX system is different than the way you do it on HPUX. So if you're a vendor of job scheduling technology, you have to write application-specific versions of your technology to each platform. Tivoli said, come to the client, if you buy this framework, you can run all of those things across all your platforms. Customers said, gee, I want to run all those things across all those platforms. I'll buy TME. And they bought it and they installed it. And then they called the salesman up and said, where do I turn it on? And the salesman says, no, we don't sell those. But because you have Tivoli, you can do all of those things. It's like, get out of here. You know, I don't want to buy this. I want to buy those. So they've actually realized that the reason you buy frameworks is not because of the glory of them, but because it solves a business problem, and you end up having to buy more than one because the range of technologies is incomplete, the range of platform support may not match your actual technology deployment. Which leads to the fourth finding. Buy the product you need to solve the problem you need to solve. In some instances, a suite may be appealing. It may have a number of the platforms you need. In other instances, you may just want to go with a backup product without regard to which particular framework it runs on. In some instances, there may be a framework that actually does meet your needs, but don't go after it for canonical reasons. Don't go after it because you like to do business with the vendor necessarily. Go after it primarily because it has the tools you need to do the job. There are excellent point solutions out there for specific technologies, and there are systems integrators all over the place to help you weld them together. And that gets to our fifth point. If you are real good at integrating multiple distributed systems management solutions, you might consider selling that as an offering. If you have a strong core competence within your IT organization on welding these things together, that's a skill that there's a market for. If you are not good at it, you might seriously consider signing up one of the boutique integration vendors to weld this stuff together. This picture is both an organization chart and also a network topology. Because what we're looking at here is an architecture, a way of organizing distributed computing that seems to work in many cases. Remember, we went through a three-phase evolution. We started out with monolithic centralized stuff, and then we went through this radical localization where anything bigger than a desktop was thrown out. And now we've come into this third phase. We call it regionalization. It's not a return to the mainframe. Regionalization means that we pick certain servers by function, and we distribute them either by operational area or by geography. But within this domain, this server, maybe for software distribution, covers these platforms. That server covers those platforms, and this server over here has no knowledge of the configuration of that workstation over there. You cellularize it. You create domains. This simplifies the problem. With a robust network, you can then do it. Now note that the topology of servers that do software distribution will have a different number of boxes with different capabilities than the set of servers that do, say, security administration or single sign-on, which will be different again from the set of servers that do backup. So you're going to have this model occurring in many different flavors with possibly different groupings of workstations across your enterprise. What we're learning is there's no such thing as a server. It's like saying you know how to speak language. You have to say what kind of server it is. Is it an application server, a backup server, security server, or whatever? And you end up with a topology that is flexible with a network that is hopefully robust. And if you do it well, you're only going to spend 2.5 times as much as you would have spent in a centralized environment for the same application functionality. This chart is an attempt to describe one way of organizing the thinking about all of the different distributed systems management techniques. We've got 4 domains: systems management, network, asset, application, that's where software distribution gets in, and data, that's where database management administration comes in. What we're saying is that all of these things have a set of activities that you do before you start the application. They're like pre-flight. That collection of activities are collectively configuration-related disciplines. And so a configuration management utility of some kind will become a key application in your DSM product suite to cover that half of all of these things. You know, where is this stuff? What is on each desk? Who's got the software contract? Licensing is getting more and more important. What is the connectivity to the various stations? And then there's a whole other set of things that you got to do real time while the application is running. Call it air traffic control. It's in-flight stuff as opposed to pre-flight stuff. Event handling, exception reporting on performance conditions, and so forth. If you think about splitting the suites of technology into things that are more configuration related versus those that are runtime, event related, then it might clarify your IT architecture. I'm not saying this is the right answer, but this model may help move you forward when you define your user information architecture. The 8th commandment is really more futuristic. Given that people have the open environment with SNMP-based agent handling technology, as well as legacy environments with intelligent agents, is any vendor selling a stupid agent? I didn't think so. We're all just getting smarter every day. Both of these things are going to end up having to talk to an integrated network and systems management platform of some kind to bring this stuff together. But when you go from there, I'm encouraging you to think about these kinds of efforts, to think about an engine to do automation. And there are many levels of automation. The simplest is just suppressing unnecessary messages, right? VTAM IEA 0001I, terminal so-and-so logged on. Terminal so-and-so logged on. I don't care. Of course they're logged on. They work here. You know, you want to just turn off all of those messages. Second level is to give additional information to the operator. This message means that user Joe has just logged on. Oh, that's nice. I needed to know that. The next level of automation, the third level, is where you're actually able to respond to some message. Reply you to use tape. Reply you, reply you, reply you. Can we get a computer to do this? The fourth level is where you start putting in scripts to deal with frequently occurring situations. And the fifth level of automation is where you have some kind of correlation, chronic event handling. We're able to take a look at the correct state and say these symptoms say something's about to happen. That fifth state is just beginning to show up. That's where you have technologies that learn, that accept training, that modify themselves. This is where the real, ad tech stuff like neural net type technology shows up. You want to be able to reduce your dependence on people. A study done at IBM in the mid-1980s indicated that operators, when they do things, do the wrong thing about 40% of the time. 2 out of every 5 things an operator does are in some sense incorrect. So the solution is to have operators do fewer things, right? Automatic tape libraries are nice. That way you don't mount the wrong tape and so forth. Move towards that as an end game. 9th commandment says, focus on business objectives. As you are building these suites and tools, you're moving in this direction. Most of us, for most of the time, are actually below the bottom of the pyramid, where we're responding to incidents rather than comparing the state of the system with a policy. We still haven't gotten policy-based systems management in place across all of our platforms. As you do that, you can begin to derive some general rules and policies within the IT organization, which are specific manifestations of your overall objectives. These are service level objectives. These are contracts with the end user as to what it is they expect and how much they're going to pay for it. Those IT objectives must relate to overall business objectives. And finally, get out your checkbooks. This stuff, if you do it well, it's expensive. If you do it poorly, it is extremely expensive. This chart, which is constant $1995, talks about what we think the growth in the market will be. There'll be inflation on top of that and so forth. This is worldwide. By comparison, spending, again, scrubbing inflation, constant dollars for host-based systems management is now about $3.5 billion, and it is contracting slowly. Will dip below $3 billion in 98 or 99. Okay? So the amount of money that people are throwing at this problem is growing fairly dramatically as we go across our 5-year planning horizon. So vendor survival, a magic quadrant. Again, just to refresh, the way we work these things as you move towards me on this side, this is the Gartner Group assessment of how well these vendors understand and can articulate the needs of the customers in the space they intend to serve. How well do the vendors really know what it is that you all want in their particular domains? And the chart should be titled, which distributed systems management vendors will have the most impact on user architectures. The vertical axis is our assessment of how well these companies are in terms of executing whatever strategy it is they've got. We'll forget about whether the vision's good or bad, but let's look here vertically. How deep are their pockets? How good is their sales force? How effective are the channels they use? How well do they support the technologies that they ship? How good is their management team? What kind of financial backing do they have? That's the vertical axis. The most important thing is to remember to compare like for like and to watch the motion of the dots as we go from year to year. We create these charts and then we enhance them on a year-to-year basis. So you take a look at how the dots move. Generally speaking, a company comes into existence here. We don't know much about them. We don't know much about their management. We're not sure what their vision is. Over time, as they articulate their vision, if they really get it, the dot moves this way, into this visionary box. Then an interesting thing happens. After you hung out here for a while, you got to start selling some product. Instead of talking to prospects, you're now talking to existing customers. Existing customers have very high expectations of service. They want to see quality. Investors want to see financial results now. And so the dot tends to move in that direction as the company reins itself in, scales back the vision thing, and begins to work on execution. So the dot moves in a Z-shaped fashion to the upper left-hand corner where it's a challenger. And then, if the company has it together, they'll move to the right again with a wider and more compelling vision addressing a broader set of requirements, and that'll move them into the leadership box. Ever since 1989, the groups in Gartner that deal with systems management, both classical host-based and also distributed systems management, cover about 400 vendors offering thousands of products. Every year since 1989, 1 out of every 3 vendors goes away. They fold up their shop, they merge with somebody else, or they get acquired by Computer Associates. It's a dynamic environment. What does that mean? Well, it means that the odds are even that 2 years down the road, whichever vendor you pick ain't going to be there, which means from an investment perspective, if you can't get your money out of that systems management investment within 24 months, think again.